All right, so we're going to look at 25.3 at multiplying polynomials. So this lesson, our learning targets are use a graphic organizer to multiply polynomials and use the distributive property to multiply polynomials. All right, so the graphic organizer would be that box method. So a graphic organizer can be used to multiply polynomials that have more than two terms, such as a polynomial times a trinomial. The graphic organizer at right can be used to multiply x plus 2 and then x squared plus 2x plus 3. So draw a graphic organizer in the My Notes section, and we're going to multiply x minus 3 and then x squared plus 5x plus 6. All right, so draw the box that looks like this. So here we have a binomial, so we have 2 this way, and then a trinomial, so we have 3 down this way. So in this first box, what are they doing? They're multiplying the x squared times the x. And then in the second box, they have x squared times 2. And so it's the same process, but now you have a couple more boxes, right? So instead of having a 2 by 2, you have a 3 by 2. So x minus 3, I'm going to put that up top. And then we have x squared plus 5x plus 6. Alright, so here we have x squared times x, so what goes in this first box? X squared times x. X cubed, because we have x times x times x, so x cubed. What's going to go in this box here? Negative 3x squared. Now we're looking at this box, so what goes in this one? In this box. This last one. Perfect. All right, so now we're going to add up our like boxes. All right, so here we have 5x squared, and then up here we have negative 3x squared. Those are alike, correct? So we can combine those terms. So what's 5x squared minus 3x squared? 2x squared. And then I also have 2 x's. I have 6x minus 15x, which is negative 9x. And then I have these 2 boxes. I don't have any like terms to go with it, so I'm just going to pop them down. So x cubed and then minus 18 at the end. Now I put this in standard form, so I started with my highest degree here, so x cubed and then plus 2x squared minus 9x minus 18. That's kind of typically we put highest degree first down to our constant on the end. Questions? Not too bad, right? Same process as last week. Just multiplying 2 more boxes. So how many boxes would you need to represent the multiplication of x cubed plus 5x squared plus 3x minus 3 times x to the 4th minus 6x cubed minus 7x squared plus 5x plus 6. Right. So you would need 1, 2, 3, you need 4 for this one, and then 1, 2, 3, 4, 5 for that one, right? So you need a 4 by 5. Alright, so let's just go ahead and do it, because the next one says explain how you got your answer, and I'm sure if I scroll down, it'll say what is the answer. So let's just go ahead and set it up. Because there's no better way to conquer fear than by plunging in and doing so now for this first box, x to the fourth times x to the third. X to the seventh. And then this box, we have x to the fourth times 5x squared. And in this box, we have x to the fourth times 3x. And then this last box here, we have x to the fourth minus times negative 3. Alright, so far so good. In this box here, we have negative 6x cubed times x cubed. Perfect. In this one, we have negative x to the third times 5x squared. Negative 30x to the third. And in this box here, we have negative 6x cubed times 3x. This box, we have negative 6x cubed times negative 3. Alright, so far so good. For this one, we have negative 7x squared times x to the third. And then here we have negative 7x squared times 5x squared. And this one, negative 7x squared times 3x. In this one, we have negative 7x squared times negative 3. Alright. Are we noticing any patterns with our like terms? Alright, let's keep on going. So we have 5x times x to the third. And then this box, 5x times 5x squared. 5x times 3x. And then for this last box, alright, almost done multiplying. So then this one is 6 times x cubed. Alright, so let's go through, and we have x to the 7th here. Do we have any other x to the 7th? No. I have x to the 6th here and here. Do I have x to the 6th anyplace else? Alright, so how many? I have negative 6x to the 6th plus 5x to the 6th. So how many x to the 6th do we have? I have negative 6, and then I add 5. Alright, so circle all of the x to the 5ths. Do we have any other ones? So what's the pattern?
Like it goes 7, 6, 5, 4.
Yeah, so all your common factors are on diagonals. Alright, so so how many x to the 5th? We have 3x to the 5th minus 30x to the fifth minus 7x to the fifth. So 3 minus 30 minus 7. Kind of close. What did you get? For the x to the fifth?
I'm gonna go 34.
That's what my calculator says. Alright, so let's go through and then we're going to look at x to the fourths.
I'm gonna go 51.
Tom says negative 51. Does everyone agree? I got 21. Oh, never mind. I put the wrong sign in. So 5 minus 35 minus 18 minus 3. Yeah, negative 51.
528. 66. Plus 18x.
And then you got 3 for that one? What you said?
Those were
Negative 18. Alright, so when we multiply these together, we get this hot mess here. Is it impossible? No, but it is tedious, right? I would classify that as a chore. No one wants to do it, but someone's got to do it. And I think with this one, the graphic organizer definitely makes something like that easier. All right. Now, on Friday, we also looked at FOIL method. Now, FOIL method is really a fancy distribution where you take your first term and you just distribute it, and then your second term and you distribute it. Do you think that process would work well for one like this one?
You have to keep all track of numbers in your head.
You'd have to keep track of everything, yeah. So, you'd have to take x cubed times x to the fourth, times each of these, which is what we're doing here. We're just doing it in an organized manner. And then you have to take 5x squared and multiply it to all of your other terms, and then 3x times all of your other terms, and then negative 3 times all of your other terms, and then combine like terms. The nice thing with the box method is all of your like terms are on a diagonal, and so add through the diagonal and solve them up, or add them up. All right, so here it's using the distributive property, where you're taking the first term times everything. Let's see, so I guess let's practice a few. So looking at A, we want to determine the product. So what are we using? What property would you use? What would be your approach to solve letter A? Distributive property. Would that, for this one, would it necessarily make sense to draw up a box for it? No, I mean, we should be able to distribute that. So we have x times x, which is, and then x times 5. Now, if you wanted to draw up a box for that, you can. It would be a 2 by 1 matrix. But, I'm not going to discriminate against box here. Alright, what about B? What would be your approach? Would you do box method or FOIL? What's your preference? FOIL. Okay, so I think there's probably an even split looking at your homework between FOIL people and box people. So let's take a minute and use your method to solve, or this would be a good chance to venture into the other method. If you like to do box and you did your homework using box, then try FOIL out. If you use FOIL, try box. It's always good to know where the other side's coming from, right? All right, so for B, for your FOIL people, and for your box, it would be your first box. What did we get for the first one, for our first term? X what? X squared.
Minus 3x.
All right, and so then, so we can take our these two. So we have negative 3x, and if we do here, this would be negative 3x. So what do we get when we add those two together? When we add our O and I, our outer and inners, we got a total of how many?
Plus the 3x.
Because we'd have negative 3x and then plus 6x. So plus 3x. And then our last one, what do we get when we multiply our last terms together?
Negative 18.
Good. Alright, so now let's try the new one. So let's try C. Yep.
If you use FOIL method for B,
Yep.
wouldn't it be negative?
Nope, it would still be the same because you'd have your first would be your x times x with x squared. And then you'd have x times 6 for your outers. And then you'd have your inners, which is negative 3x. And then your last. Alright, so FOIL people, you can still use FOIL for this one. You're just going to take x times each of your terms and then 7 times each of your terms and combine. And so if we're using, I'm going to kind of do both of them concurrently so we can see how they match up and why they work. So I'm going to take x times 3x squared, which is my first box here. So what do we get here?
3x and 3.
And then we're going to take x times negative x. That would be this box here. So x times negative x is and then x times negative 1, which is this box here.
Negative x.
Now we're going to take 7 times 3x squared, which is this box here.
21x squared.
And then 7 times negative x, which is this box here.
7x.
And then 7 times -1, which is this box here. Nice thing about the box is all of our like terms are on a diagonal. So 21x squared minus x squared is and then our x's are here, so we have negative x minus 7x, so we're down an x, and then we're going further to negative 7x's, so how many x's are we down? Negative 8. Alright, and then I have 3x cubed, I don't have any like terms there, so that's just gonna get attached to the front, and then minus 7 on the end. And they're in descending order by degree, so x cubed is in the front, and then x squared, x, and then the constant on the end. So how are we feeling about that? All right, so looking at number 3, I know we didn't do D, but question 5 says, are all the answers in item 3 polynomials? So I think that if you take 2 polynomials and you multiply them together, are you going to have a polynomial? Yes. And then this is, I talked about this last week, polynomials are closed under multiplication. They said it's closed under multiplication if the product of any 2 elements in the set is also an element in the set. So if we have a polynomial and a polynomial, and they get together, they're going to have polynomials, right? Just like all of us, our parents, we're human beings, right? So when human beings get together, they make more human beings, right? Some of us live on farms or have lived on farms. When cows fall in love and get married, they create little cows, right? Cats, when cats fall in love and get married, they create little cats, right? Yeah, I know. So now so some big people need to think of Shrek. In Shrek, donkey fell in love with a dragon. Do donkeys fall in love with dragons? No. Why not?
They have little dragons.
Because we can't cross, different species. Oh, but movies happen.
The dragons are real, but it's donkey dragons.
Humans can only make humans, and so polynomials, when they fall in love and get married, only make more polynomials. That's pretty much how my brain works. All right, so here we have worked with when 2 polynomials make a family, right? So now we're going to look at what happens when we have a party. So here we've worked with a party of 2. Now we're going to have a party of 3. So you can find this product by multiplying them together. Here's the thing. You could only work with 2 at a time, right? And so when we're multiplying, if you have 3 or more polynomials, you can still only multiply 2 at a time. So we have this. And so they're choosing to work with these two first. So this one's going to hold off for a minute. And so, have any of you guys started dating? Yeah. Okay. Sometimes you can go on. You can have a full calendar, and maybe you have you're gonna go on a date with one person, and then a couple days later you go on a date with somebody else because you're not in a serious relationship. You're just kind of. When you say you're in a serious relationship, you're just going.
You're officially dating.
Or met. I didn't say it. You're just going on a date.
It's like what happens if you don't like that person?
Yeah.
Okay, great. So
You just met.
You do like the next day. You do like
All right. So these two are going on a date. These two are on a date. So these two are going on a date and they're having their dinner. So X, this scenario is not going to work out. So X times 2X is.
So basically, on this first date, they're gonna fall in love and get married and have
No.
polynomials.
They're going to have a conversation.
wait,
So let's say these two, everybody's a friend. These two, they're having a party for 3 people. They're getting to the party. So, but this person arrives first. So they're going to start the party. So they're chatting and mingling. So X times 2X is.
So they're gonna have more polynomials. They're chatting at the beginning of the party.
Don't worry too much into it. X times, they're mingling. They're not, nothing more. X times, so let's do the box method because I'm already confused. Yeah, it's speed dating. It's speed dating. Alright, so 2X times X is how much? 2X squared. And we get this box here, so 2X times 3X. And then this one. And then this one here. And combine our like terms. So this one is 2X squared plus 7X. Alright.
on the first date.
Alright, so these two got married and they have a child. But it didn't work out. So they got divorced. They got married.
They're like every Hollywood relationship.
So this is their baby, right? And now this one comes along. And now the baby and this one are gonna get married.
So two people meet at the party.
Oh my god. It's 27 to 30 years later.
It's an arranged marriage. 27.
Alright, so they got married and now an appropriate time later, after college and they started a career, they get married. So 3X minus 2. Alright?
No one likes
But it's
this.
true.
So 3X minus 2 comes along.
Oh, yeah. Yeah.
There's a reason why I don't teach biology or health. All right. So we have, what goes in this first box here?
6X.
Wait till Cole and Nate listen to this. Now what goes in the second box?
21x squared. 9x. Negative 4x squared. Negative 14x. Negative 6.
All right. All right, so we have 21x squared minus 4x squared.
You could have just
18.
It's 17.
17x.
I tried. So 9x minus 14x.
It's about
That's a really good question. I don't know. I don't.
5x.
I think it's 5x. And then we have our 6x cubed and our 6x. So 6x is going to go in the end, and 6x cubed at the beginning. So we're in descending order by degree. So 6x cubed first. So 17x squared minus 5x minus 6. And we have another happy family with a grandchild.
Oh, by the way, Austin, you might be doing chess.
And then,
Where you going?
and then 15,
Jerry.
you know, and 25, whenever they're done with college and start their job, they have a nice career on track and they have their career path down and future is safe. Bought their first house and they're going to get married.
Invest in security.
Solid foundation.
Robust.
All right. So let's do letter A. I want you to do letter A. So we have our first two are going to multiply first, and then their offspring will multiply after they have finished their, higher education, have gotten their career on track, down payment on a house. And 2 mortgages. No, yeah, or just we want nice, safe, yeah. All right, so I'll walk around, and I will answer math questions.